Myself, P. Balakrishna from EC department. Yesterday we can discuss in the delta modulation and what is delta modulation and how to share the information from transmitter receiver, and all topics are discussion. So now today we can discuss in the digital modulation techniques in the second unit. So first of all, what is digital modulation techniques? That is, the digital modulation provide more information capacity and data security and quicker system availability, a greater quality communication system. That is, the digital modulation techniques are using to convert the easy method of the analog modulation digital modulation. That is, the digital modulation techniques you can speed up transmitted the from source to destination also. Here also using the if the information signal is the digital and the amplitude is a carrier is a very proportional to the information signal, a digital modulation signal called amplitude shift keying modulation. That is simply analog modulation technique. And one more technique is FSK techniques, that is frequency shift keying modulation techniques. It is simply to vary the frequency just to find out the pulse duration of the input signal. And one more thing is a phase shift keying modulation. Here also the phase will be 90 degrees or 180 degrees, will be simply shifting the input signal through output. So this is the different techniques of the digital modulation. Simply we can study those modulation techniques. So this is simply formula for quantum amplitude modulation. So quantum amplitude modulation has mainly amplitude shift keying modulation, phase shift keying modulation and frequency shift keying modulation. Here simply we can observe that V of t is equal V sin 2 pi ft plus pi. Here we can observe that V is ACK modulation, F FSK frequency, V is the voltage amplitude, theta is the phase shift, that is the angle. So we can simply to identify the each terms. So now we can discussion one by one. First, amplitude shift keying modulation. So here the amplitude shift keying modulation, the amplitude of the resultant output depends upon the input data, whether it should be zero level or variation of positive or negative level. Simply is depending upon the carrier frequency. That is, the carrier frequency signal is a high frequency signal, and then simply the position of the low and high. Simply the amplitude will be shift in the left or right side of the origin. So here easily to find out that amplitude shift keying. And one more thing is amplitude shift keying is the type of amplitude modulation which represented the binary data in from variation in the amplitude of the signal is the one of the variation of the signal, simply to shifting of the data. So following the diagram we can observe that so this is simply we can observe that input binary frequency, that is the high and low values, increase and decrease values. And one more thing, ASK modulation output. Here input is high, at same time amplitude will be increased. So input is zero level, amplitude will be simply stability condition. And once again input is high, amplitude will be increasing, that is 1 and 0. So input is 1, output is also 1. Input is 0, output is also 0 condition. This is simply ASK modulation output waveform. So this is the equation of the modulation signal has a high frequency carrier. The binary signal when ASK is modulated when given a 0 value is low input and given the carrier output for high input. This is the mathematical representation of the equation, that is amplitude shift keying and digital information signal unmodulated carrier amplitude average and analog carrier radio frequency per seconds. So this is simply mathematical representation of the amplitude shift keying modulation. So in the above equation is the modulated signal normalized binary waveform when 1 volts. That is simply to represent it which data and which time can transmitted some negative to positive negative. How to define? Here the VSK, way amplitude shift modulation or maximum are equal to the A cos omega c t, and mathematically is represented in the amplitude shifting modulations also. So next continuation is same equation is there. You can define that plus 1 volts is 1, minus 1 logic is 0. That is 0 and below of the minus, above is positive 1. So you can represent it amplitude shift modulation, but 1 minus 1, that is A by 2 cos omega ct. That is nothing but amplitude shift modulation time are equal to the 0. That means both are is a 1 minus 1, that is a negative terms, so you can represent simply 0, then you can multiply the total input signals also. So this is simply to find out the amplitude shifting modulation is one on-off keying modulation also. On-off keying modulation also. And also you can represent it that some examples is there. You can determine the bound and minimum bandwidth necessary to pass the 10 kilobits per second bandwidth signal using amplitude shift key. This is simply to identify that binary digits. So here the n is 1. So bound and minimum bandwidth are determine the equation. So this is simply how to define. So your bandwidth are equal to FB by 1. That is bound are equal to FB by 1. This is a simple formula, and we can simply to simplify to apply that formula, and we can use that how many bound and minimum bandwidth. So you can simply to find out that. So this is simply examples of the ASK modulation. And one more thing here, simply to define that modulated signal and is a mixer to apply the carrier wave, and output is a ASK modulation signal. This is one of the examples of ASK modulation signal. The input bandwidth sequence applied to the product of the modulator, that is the summation. The product of modulator amplitude is modulated the sinusoidal carrier. It is passed the carrier with the input bit 1. Simply it blocks the carrier when input is 0. Next we can continuation. So frequency shift keying modulation. So tomorrow we can discussion the frequency shift keying modulation. Thank you one and all.